Let's look at some quadratic inequalities. So what is a quadratic inequality? We call it a quadratic when we see an x squared as the highest power in the function, and inequalities because of the existence of these signs here, the less thans and greater than signs, your inequality signs. So before we look at solving these inequalities, let's do a little bit of background work on quadratic functions. So here I have just a basic graph of any quadratic function of the format ax squared plus bx plus c. We have our x-axis and we have our y-axis. Now on the y-axis, we know that the y value is 0 right here. These are all the positive y values. These are all the negative y values. All right, so keep that in mind. So the first thing we're usually interested in a quadratic graph is the roots. Now the roots is where the function cuts the x-axis. So right here and right here, these guys are the roots. So the roots are the points where the function cuts the x-axis. Now you already know how to find roots. Anytime we want to find the roots of a quadratic equation, we simply let the function equals to 0, because this is where the function, the output of the function will be 0, because this is 0 on the y-axis. So here and here, the function equals 0 because the output is 0. So let's develop this a little bit further. So once again, we look at the same quadratic function. Below the x-axis, down here, this is where all the y values are negative. In other words, where all the y values are less than 0. All right. So in other words, the output of the function is less than 0 down here. All right. So this part of the function that I'm highlighting right now, this is the part of the function that's less than 0, because it's below 0 here. It's below the x-axis. So this part of the function is less than 0. Now, if we examine this part of the function, we could say that there's an infinite amount of points along here, but let's just pick a couple of them. So I'm just going to highlight a couple of points along this part of the function that is less than 0. Now, as we already know, every point has a specific x value and a specific y value. Every point has a specific x value and a specific y value. So remember, we have our x values here and our y values here. So every point along this way has specific x values and y values. Now, if we look at the y values here, all the y values we mapped onto are all of these y values here. These are all the y values that are less than 0. All right, and we already know that. These are the y values that are less than 0. But what's more interesting for us right now is what are the x values? So you should notice that the x values are all of these x values here. These are the x values that we mapped onto. So between here and here are the x values. So for these x values here, the function itself is below 0, or the function is less than 0 for these x values here. Now what's interesting about those x values is, remember, they are the x values that are in between the two roots. So remember, they're my roots right there. And for all of the x values in between the two roots, the function itself is less than 0. So if you use any of the x values in between the two roots as an input of a function, the output is going to be less than 0. And we can take this a little bit further again. So let's have a look at one more example here. So here's the same function again. Okay. And now we're interested in the part of the function that is greater than 0. In other words, for the positive y values, where the output is greater than 0. So that would be this part of the function here and this part of the function here. This is where the function is above the x-axis, greater than 0. Now, same again, there's an infinite amount of points here. Let's just take a couple of them. All right. And remember that every point has an x value and a y value. You have x values and you have your y values. X, y. X values, y values. So every one of these points has your input as your x value, your output is your y value. Your input is your x value, your output is your y value. So you have your x values as your inputs and your y values as your outputs. Now we know that all of these y values are all the y values that are greater than 0. all right, because it's where the function is greater than 0, where the outputs are greater than 0. What's more interesting is the x values associated with all of these points. If we look at the x values we're mapping onto, are these x values out this way, and these x values this way. In other words, they are the x values that are outside the roots, right? Outside the two roots, all right? So when you care about where the function is greater than 0, you care about the x values outside the roots. So we had 3 different scenarios here. All right, remember, when you have the left, when you're looking for the roots, you put the function equals to 0. All right, so the roots is where the function equals 0. If you care about where the function is less than 0, therefore you generally care about the x values in between the two roots. And if you care about where the function is greater than 0, you care about the x values outside the two roots. Now, it's important to understand that what I'm referring to is all for positive x squared quadratics. In other words, where your a value is going to be greater than 0. The reason we discussing only positive x squared quadratics is positive x squared quadratics will be u-shaped, and all of this theory applies to u-shaped quadratics. If you had a negative x squared quadratic, everything would be reversed. So negative x squared quadratics look like this, and everything I've just told you would be reversed. But for this tutorial, we are only dealing with positive x squared quadratics with u-shaped quadratics. So let's develop this further with an example. So here I have the quadratic function x squared minus 3x minus 18. So the first thing I'm going to identify on this quadratic function is the roots. All right, remember the roots is where the function equals 0. So if we zoom in, here's my root at x equals minus 3, and here's my root at x equals 6. So that's straightforward enough. That's something we already know. The roots, where the function equals 0, is where it cuts the x-axis. So that's what we have right here. The next thing, let's have another look. Now let's be interested in where the function is less than 0. So we already said, if you remember the previous situation, when we're looking at where the function is less than 0, we care about the values in between the two roots in this particular case. So if we care about where the function is less than 0, we care about this part of the function here, below 0, but the x values we care about are the x values in between the two roots. Now, once again, if we zoom in, you can see that those roots are at x is equals to minus 3 and at x is equals to 6, right? But what we care about is the x values in between the two roots. So where is the function less than 0? This function will be less than 0 when x is between minus 3 and 6. And we write that like this. When x is between minus 3 and 6, this function is less than 0. So now we're going to analyze the values for where the function is greater than 0. So if we go back, remember, if we care about where the quadratic function is greater than 0, we really care about the x values outside the roots. So going back to our example here, once again, I'm going to zoom in for you just so we can see it's the same one. We have one of the roots is x equals minus 3, and the other root is x equals 6. So having a closer look here, we now care about where this time, where is the function greater than 0. So remember, the function's greater than 0 up here and up here. But what are the x values? The x values are the x values outside the roots, as we've already discussed, outside the roots. So this function will be greater than 0 when x is greater than 6 and when x is less than minus 3. When x is greater than 6, you can see that the function is greater than 0. And when x is less than minus 3, you can see that the function is greater than 0. Okay, let's go back to the original question now and see can we use what we've just learned. So I'm going to have a look at question 1 here for you. So x squared plus 2x minus 15 is greater than 0. X squared plus 2x minus 15 is greater than 0. So what do we know so far, right? We know that this is a quadratic function. So we know that we're dealing with some sort of U-shaped quadratic. And we care about where the function is greater than 0. All right, so we care about this part of the function up here and this part of the function up here, which, as you already know by this stage, is the part of the function outside the roots that we care about. We care about the x values outside the roots. Okay, so in order to describe what these x values are, we need to know what the roots are. So the first thing I got to do before I can tell you what these x values are is I actually have to go ahead and find the roots. So we know how to find the roots of a quadratic function. We know to find the roots, we just put the function equals to 0. So that's what I'm going to do. X squared plus 2x minus 15 equals 0. And we just solve this simple quadratic. X plus 5, x minus 3 equals 0. X plus 5 equals 0. X is equal to minus 5. X minus 3 is 0, so x is equal to 3. So minus 5 and 3 are my roots. So I've found the roots for the quadratic function, so I can use that to help me describe this region. So this here is x is equals to 3, and this here is x is equals to minus 5. So what is the answer to the actual question then? So the answer to the question was, where is this quadratic function? Where is the quadratic function greater than 0? And we have the answer on a graph. We can see that it's greater than 0 for these x values here and these x values there. But what are those x values? Well, these x values here, they're the x values that are less than minus 5, comma. These x values here, they're the x values that are greater than 3. So the answer to the quadratic inequality, for what values of x is the quadratic function x squared plus 2x minus 15 greater than 0? Well, for all x values less than minus 5 and for all x values greater than 3, for all x values less than minus 5 and for all x values greater than 3, the function itself will be greater than 0. Okay, let's look at one more example for you guys. So here we have one more quadratic inequality. 21 minus 4x minus x squared is greater than or equals to 0. So the first thing you'll notice here is I have a negative x squared. So I don't like working with a negative x squared. My advice to you, if you see a negative x squared in a quadratic inequality, is to take the whole line and multiply it by minus 1. Which will change it from a negative x squared into a positive x squared. It'll change all the signs. So negative x squared will become positive x squared. Minus 4x will become plus 4x. 21 will go to minus 21. And here's where we have to be careful. Less than or equals to 0. The inequality sign changed direction. And you have to remember, if you multiply or divide by a negative, you have to change the direction of the inequality sign. So that's why I changed it from a greater than or equals to a less than or equals to, because I multiplied by a negative. All right, so now we're in familiar territory. We have a quadratic function and we care about where it's below 0, less than or equals to 0. So once again, I'm going to do my quick sketch. And I care about where the function is below 0. So I care about this part of the function down here. All right. And actually less than or equals to 0. So I'm including the roots with this one. Now we already know, we've discussed it a couple of times, if we care about where the function is below 0, if we care about where the function is less than 0, we generally care about the x values in between the two roots. So going back here, we care about the x values in between the two roots. These x values in here. All right, they're the x values we care about. What are those x values? Well, we don't know yet until we find the roots. So let's go aside here and find the roots. Remember, to find the roots, you put the function equals to 0. So I'm talking about this particular version of it when we change the signs to the positive x squared. So x squared plus 4x minus 21 is equals to 0. x plus 7, x minus 4 is 0. So you end up solving for your roots. X is minus 7, and your other root will be x is equals to 4. So we've got x is equal to minus 7 and x is equals to 4. They are my roots. So once I have found my roots, I can put them into my diagram. So the roots, as we just found, are x is equals to minus 7 and x is equals to 4. Okay, now back to the question. We cared about what were the x values in between the two roots. So these x values here, well, they're above minus 7, but they're below 4. So they're between minus 7 and 4. So when it's all one region, when it's above minus 7 and below 4, we will say that our answer for where the function is less than or equals to 0 is between minus 7 and 4. So that's how you write it. You write your x between your minus 7 and 4. And the one thing we have to remember is if there's an or equals to in the question, you see up here there's an or equals to. If there's an or equals to in the question, there's an or equals to in your answer. So this right here is my answer. When x is between minus 7 and 4, including minus 7 and 4, including the roots, that's when the function will be less than or equals to 0. So that is the introduction to quadratic inequalities. The best thing for you guys to do is to go ahead and practice some of these questions, check your solutions. And for access to questions, solutions, graded quizzes, and more, visit www.limymaths.com.